Do the world and space have boundaries? Where does the world begin? Earth's gravity does not simply stop where the atmosphere becomes thin. Gravity has no edge. It weakens with distance, but it never fully disappears. Every object with mass exerts gravitational influence, and Earth is no exception. Even far beyond the exosphere, long after the last traces of atmospheric particles have vanished, Earth continues to pull. This is why defining the true end of Earth becomes a question not of air, but of dominance. In space science, dominance is measured by something called the Hill sphere. The Hill sphere is the region of space where a planet's gravity is strong enough to control the motion of nearby objects against the competing gravitational pull of a larger body, such as the Sun. For Earth, this region extends roughly 1.5 million kilometers into space. That is nearly 4 times the distance to the Moon. Within this vast, invisible bubble, Earth remains the primary gravitational authority. Satellites, debris, and even the Moon itself exist within Earth's gravitational reach. In this sense, Earth does not end at the sky. It does not end at the Kármán line. It does not even end where the atmosphere fades away. Earth ends where its gravity finally yields control to the Sun. And even this end is not a sharp boundary. It is a region of balance, where gravitational forces compete rather than abruptly switch off. This realization changes how we think about our planet. Earth is not just a rock wrapped in air. It is a sphere of influence, extending far into the darkness of space, quietly shaping motion, paths, and orbits. This is why the Moon is bound to us, why artificial satellites remain loyal to our planet, why space debris circles Earth instead of drifting away. The line between Earth and space, then, depends entirely on perspective. From a pilot's perspective, space begins where air is too thin to fly. From a physiologist's perspective, it begins where the human body cannot survive without protection. From an engineer's perspective, it begins where aerodynamic lift fails and orbital mechanics take over. From a lawyer's perspective, it begins where national airspace ends and international space law begins. From a physicist's perspective, it begins nowhere at all. This ambiguity is not a flaw in our understanding. It is a reflection of reality. Nature rarely provides clean borders. The ocean does not end at the shoreline. It transitions through waves, spray, mist, and humidity. The forest does not end at a line. It thins into shrubs, grass, and soil. Day does not end abruptly at night. It fades through twilight. Earth behaves the same way. As humans began to fly higher and higher, this truth became impossible to ignore. Early high-altitude balloon missions pushed explorers to the limits of survival. At extreme altitudes, oxygen starvation sets in quickly. Blood oxygen levels drop, vision narrows, consciousness fades. Above roughly 19 kilometers, a terrifying phenomenon occurs. Without sufficient pressure, bodily fluids begin to boil at normal body temperature. Saliva bubbles. Tears vaporize. The lungs collapse. This is not because of heat, but because pressure has fallen too low to keep liquids stable. This environment is already far below the commonly accepted boundary of space. Even before reaching the Kármán line, Earth has become deadly. This is why spacesuits are not simply warm clothing. They are mobile life support systems. They provide pressure, oxygen, temperature control, and radiation shielding. Without them, the edge of space would be instantly lethal. Aircraft are bound to Earth because they depend on air. Wings generate lift by deflecting air downward. Remove the air, and lift disappears. No matter how powerful the engines, an airplane cannot fly in a vacuum. Spacecraft do not fly at all. They fall. A spacecraft in orbit is constantly falling toward Earth. The only reason it does not crash is because it is moving sideways fast enough that as it falls, the planet curves away beneath it. This balance between forward velocity and downward acceleration creates orbit. This is why reaching space is not just about altitude. It is about speed. You can travel straight up to 100 kilometers and fall back down without ever entering orbit. Or you can orbit Earth at lower altitudes if you move fast enough and compensate for atmospheric drag. The International Space Station orbits at around 400 kilometers above Earth's surface, yet it must regularly fire its engines to maintain altitude. Even there, Earth's atmosphere has not completely vanished. It continues to whisper against the station, stealing energy, slowly pulling it down. This is a reminder that Earth never fully lets go. Even space itself is shaped by Earth's presence. The planet's magnetic field stretches tens of thousands of kilometers into space, forming a protective bubble known as the magnetosphere. This invisible shield deflects charged particles from the sun, preventing them from stripping away the atmosphere and bombarding the surface with lethal radiation. Mars, which lost much of its magnetic field billions of years ago, offers a stark contrast. Without strong magnetic protection, its atmosphere was gradually eroded by solar wind, transforming it from a potentially habitable world into the cold, thin, barren planet we see today. Earth's ability to retain its atmosphere is not guaranteed. It is an active, ongoing process, maintained by gravity, magnetism, and geological activity. This makes Earth's boundary with space not just a location, but a dynamic system. As humanity moves toward a future of routine space travel, this system becomes increasingly important. Space tourism companies promise suborbital flights that briefly cross the recognized boundary of space. Passengers will experience minutes of weightlessness, a curved horizon, and the darkness above the sky. But will they truly be in space? Legally, scientifically, and philosophically, the answer depends on who you ask. Suborbital vehicles cross the Kármán line but do not enter orbit. They touch space and return. They skim the edge without fully leaving Earth's influence. Future spacecraft may blur this line even further. Spaceplanes, hybrid vehicles, and reusable launch systems challenge traditional definitions of flight and space travel. As technology advances, the question of where Earth ends may become less about altitude and more about function. One day, humans may live in habitats that drift between Earth and the Moon. Artificial gravity may replace planetary gravity. Atmospheres may be manufactured rather than inherited. When that happens, the boundary between Earth and space will no longer define the limits of human life. But even then, Earth will remain special, because Earth is not defined by where it ends, but by what it supports. It supports oceans of liquid water, a stable climate, a protective atmosphere, a magnetic shield, a biosphere rich with complexity and balance. From space, Earth appears as a fragile blue sphere wrapped in a thin, glowing veil. That veil is the atmosphere, the very thing that blurs the line between planet and cosmos. Seen from orbit, there is no border drawn across the sky. There is only a gentle gradient from blue to black. This is the truth behind the question. Earth does not end where space begins. Earth becomes space, and space does not begin as an emptiness. It begins as the thinning presence of home. We are not creatures standing at the edge of Earth, peering outward. We are creatures born deep within Earth's extended body, slowly learning how far it reaches and how delicate it truly is. In understanding where Earth ends, we learn something far more important. We learn where we belong. When we talk about Earth ending and space beginning, we often imagine a vertical journey. We picture ourselves rising straight upward, leaving the ground behind, piercing the clouds, and eventually breaking free into the blackness above. But Earth is not defined only by height. It is defined by interaction. Even far from the planet, Earth continues to interact with its surroundings. Its gravity shapes trajectories. Its magnetic field guides charged particles. Its atmosphere, though thin, still brushes against passing objects. Earth reaches outward not like a wall, but like a fading presence. This is why satellites do not simply float freely. They are constantly negotiating with Earth. Every orbit is a conversation between forward motion and gravitational pull. Every correction burn is a reminder that Earth is still there, still influencing, still asserting itself. The idea of space as an empty void is misleading. Space near Earth is crowded with forces. Gravity wells overlap. Magnetic fields collide. Radiation flows. Particles stream outward from the sun and inward toward planets. Earth exists within this environment, not separate from it. The sun constantly bombards Earth with energy. Solar wind pushes against the magnetosphere, compressing it on the day side and stretching it into a long tail on the night side. This interaction creates space weather, which can disrupt satellites, power grids, and communication systems. Even this interaction does not have a clear boundary. The magnetosphere gradually weakens with distance. Charged particles drift, scatter, and recombine. Once again, Earth does not end abruptly. As humans ventured into space for the first time, this lack of a clear boundary became deeply personal. The first astronauts did not feel a moment where Earth suddenly vanished. They felt continuous change, acceleration, vibration, noise, pressure, then silence. The sky darkened not instantly, but gradually. Blue faded into indigo, indigo into violet, violet into black. The stars did not suddenly appear. They slowly emerged as the scattered sunlight disappeared. This experience revealed a truth no equation could fully capture. Earth does not release you. You leave it slowly. Even in orbit, astronauts report a powerful psychological connection to Earth. Looking down, they see no borders, no lines dividing nations, no edges marking continents, only a glowing sphere wrapped in a thin, delicate atmosphere. This thinness is deceptive. It is everything. The atmosphere may seem vast when viewed from the ground, but from space it is shockingly fragile. A paper-thin shell protecting all known life. A narrow margin between survival and vacuum. This fragility is why defining the boundary between Earth and space matters. It forces us to confront how dependent we are on a system that is both resilient and vulnerable. Climate change, atmospheric pollution, and orbital debris all operate within this boundary region. They blur the line between Earth and space in dangerous ways. Orbital debris, for example, exists in a region that is neither fully atmospheric nor fully free of Earth's influence. Defunct satellites, fragments from collisions, and abandoned rocket stages circle the planet at incredible speeds. These objects threaten active satellites and spacecraft. A single collision can create thousands of fragments, each capable of causing further damage. This cascading effect, known as the Kessler syndrome, could make certain orbital regions unusable for generations. Here, the boundary between Earth and space becomes a zone of responsibility. Who owns orbit? Who cleans it? Who is accountable when damage occurs? International space law attempts to answer these questions, but it struggles with the same problem science does. Space has no clear beginning. Airspace is sovereign. Space is shared. But where does one end and the other begin? As space tourism grows, these questions will no longer be theoretical. Private citizens will cross recognized boundaries. Companies will operate in regions once reserved for governments. Some flights will cross the Kármán line and return. Others will orbit briefly. Still others may remain in space for days. Each of these scenarios challenges our definitions. From a biological perspective, humans are not meant for space. Our bodies evolved for Earth's gravity, pressure, and radiation levels. In microgravity, muscles weaken, bones lose density, fluids shift upward, vision changes. Long-term exposure to space radiation increases cancer risk and damages DNA. These effects occur not because space is evil or hostile, but because Earth is unusually protective. Earth's atmosphere absorbs radiation. Its magnetic field deflects charged particles. Its gravity maintains fluid balance in the human body. Remove these supports, and the human organism struggles. This makes Earth not just a place, but a condition. At what point does gravity become too weak to matter? At what point does air become too thin to protect? At what point does Earth's influence fade into insignificance? There is no single answer. For a satellite engineer, Earth ends where stable orbit can no longer be maintained without excessive fuel. For a biologist, Earth ends where unprotected life cannot survive. For a physicist, Earth ends nowhere at all. This layered understanding mirrors the layered atmosphere itself. Troposphere, stratosphere, mesosphere, thermosphere, exosphere. Each layer marks a shift, not a boundary. Beyond them lies interplanetary space. But even there, Earth is not absent. Its gravity still bends trajectories. Its presence still matters. Only far beyond the hill sphere does Earth finally relinquish control. Even then, its material continues onward. Atoms lost from the atmosphere drift through the solar system. Some may one day become part of another world. In this sense, Earth never truly ends. It disperses. The atoms that make up your body were once part of ancient stars. The atoms that leave Earth today may one day become part of something else. Earth is not isolated. It is participating in a cosmic cycle. This realization reframes the original question. Where does Earth end, and where does space begin? The honest answer is that Earth and space are not opposites. They are stages of the same continuum. One fades into the other without ceremony or announcement. The boundary exists not in nature, but in our need to categorize, to name, to define. And perhaps that is the most human aspect of this question. We draw lines not because nature provides them, but because we need them to navigate understanding, law, and exploration. As humanity moves outward, these lines will continue to shift. What we call space today may one day feel as familiar as the sky does now. But Earth will always remain the reference point, the place where air is thick enough to breathe, where gravity is strong enough to walk, where water flows freely, where life emerged and learned to look up. Earth ends not at a line in the sky, but at the limits of what it makes possible. And space begins not as emptiness, but as the gradual absence of those conditions. Between them lies a vast, beautiful gradient, the frontier we are only just beginning to understand. As we reach the end of this journey, upward, outward, and inward, the question we began with still lingers, quieter now, but deeper than before. Where does Earth end, and where does space begin? After all the layers, all the physics, all the definitions, the answer is no longer a simple point on a scale. It has become a story. Earth ends differently depending on how you approach it. For a child looking up, Earth ends at the clouds. For a pilot, it ends where engines strain and wings lose their grip on the air. For an astronaut, It ends somewhere between the fading blue and the endless black. For a physicist, it does not end at all, but stretches outward through gravity, magnetism, and time. What we call space is not a separate realm waiting beyond a gate. It is the continuation of Earth's environment as it thins, cools, weakens, and finally blends into the wider universe. There is no moment of departure where Earth says goodbye. There is only distance. This realization changes how we see our planet. Earth is not a closed object sitting in isolation. It is open, connected, and constantly exchanging matter and energy with its surroundings. Atoms escape its atmosphere. Radiation pours in from the sun. Gravitational forces weave it into the choreography of the solar system. Earth is not separate from space. Earth is part of space. And yet Earth is also unique. Nowhere else that we know of does space become this gentle. Nowhere else does it slow itself down enough to form oceans, clouds, forests, and minds capable of wondering where they are. From space, Earth's atmosphere appears as a thin, glowing arc hugging the planet's curve. It is shockingly small, a fragile skin between life and vacuum. Everything that has ever breathed, dreamed, built, or questioned has existed beneath that delicate veil. That thinness is the true boundary, not the Kármán line, not a specific altitude, not a legal definition or an engineering threshold. The real boundary between Earth and space is the point where conditions stop being forgiving, where protection fades, where survival becomes struggle. Earth ends where it can no longer take care of us. And space begins where it no longer does. This understanding carries responsibility. If Earth's boundary is gradual, then damage is not contained. Pollution does not stop at the sky. Debris does not remain neatly in orbit. What we do on Earth affects the space around it, and what happens in space affects life below. The boundary is shared. As humanity stands at the edge of a new era, launching more machines, more people, and more ambitions beyond the atmosphere, we are redefining our relationship with this boundary. We are no longer just asking where space begins. We are asking how to live responsibly near it. Perhaps one day, humans will live permanently beyond Earth's atmosphere. Perhaps children will be born in orbit, or on the moon, or on distant worlds. For them, Earth's boundary may feel as distant and abstract as the edge of the ocean feels to us now. But even then, Earth will remain the reference point, the place where air is thick enough to sing through lungs, where gravity is strong enough to hold bodies together, where time is measured by sunrises and sunsets, where space learned how to become life. In the end, the question of where Earth ends and space begins is not about geography. It is about perspective. It reflects our desire to understand our place in something vast, silent, and ancient. Earth does not end at a line in the sky. It fades gently into the cosmos. And space does not begin as emptiness. It begins as the quiet absence of home. Between the two lies not a border, but a transition, one that reminds us how rare, how delicate, and how extraordinary our world truly is. That thin blue glow is not just the edge of Earth. It is the edge of everything we know. And for now, it is enough.